Hello students, welcome to the Schooling Hub. Today we will do Logarithm chapter of Unit Algebra. Before starting, please do like and share our videos and subscribe to our channel. Before starting the exercise, let us see the logarithm equation. The logarithm equation we have is log of a to the base b is equal to x. This is the logarithm form of equation. We will change it into the exponential form as b raised to power x that is equal to. So if we have any logarithm equation, we can change it in the form of exponential as b raised to power x is equal to a. So first question for our exercise is express each of the following in the logarithm form. First of all, let us write the equation. We have an equation for logarithm that is log of a to base b is x. This is the logarithm form, and we have exponential form that is b raised to power x is a. So here in the question we have to express them in the logarithm form. This is in the exponential form as b raised to power x that is a. For logarithm form we have log a to the base b that is x. We have log b is 10 that is base 10. A we have is 1 lakh that is log of 1 lakh to the base 10 that is equal to x, which we have is 5. Similarly here we have the form b raised to power x that is a. We will change it in the logarithm form log of a. A we have is 16 to the base b that is 6 that is equal to x that is y. This is the logarithm form. We have the next part that is 1 divided by 5 raised to power minus 3 is equal to 125. The form we have is exponential form. We will change it in the logarithm form that is log of a that is 125 to the base b which is 1 divided by 5 which is equal to x that is minus 3. Similarly here we have the exponential form 9 raised to power minus 4 which is 1 divided by 6561. We have the exponential form. To change it in the logarithm form we have log of a which is 1 divided by 6561 to the base b that is 9 which is equal to x minus 4. We have the second question. Express each of the following in the exponential form. Now we are given the logarithm form. That means log of a to base b is x. We will change it into the exponential form that is b raised to power x is a. Here if we see this equation b, we have as 11 raised to power x that is 2 which is equal to a which is 121. Similarly here this is the logarithm form. We will change it in the exponential form. b we have as the base that is 25, x which we have is 1 by 4 which is equal to a that is under root 5. We have the next part log of 6 root 6 to the base under root 6 is 3. We will change it in the exponential form. For b we have the base that is root 6 raised to power x that is 3 which is equal to a which we have as 6 under root 6. Similarly the next part we have, first of all we will write it in the form log of 0.25 to the base 2 is minus 2. Now we will change it in the exponential form as b base we have 2, x that is minus 2 which is equal to a that is 0.25. That means 2 raised to power minus 2 which is equal to 0.25. Our third question is convert the following. 4 as an exponent of 10, which means that we have say 10 has any power say x which is equal to 4. Means 10 raised to power any x is 4. That is 4 is the exponent of x with raised to power with raised to any power, we say it as x. Now if we see that according to logarithm, we know that b raised to power x is a, and its log form is log of a to base b is x. So similarly, if we will see this equation, that is 10 raised to power x is 4, in the logarithm form, this will be log of a, which is 4, to base, that is 10, that is equal to x. So here the value of x is 10, log of 4 to the base 10. Now we will put this value of x in this equation. The equation was 10 raised to power x, that is 4. 10 raised to power x is equal to log of 4 to base 10, that is equal to 4. Hence this is 10 power of log 4 to base 10, that is equal to 4. We have the next part, that is 7 as an exponent of 5, which means that 5 raised to any power, we say x, is 7. This states as 7 exponent of 5 with any power x. This is the exponential form of log. So according to logarithm, we have that b raised to power x is equal to a, which is exponential form, can be written as logarithm form in this way. So here log of a, that is 7, to the base, that is 5, which is equal to x. Now value of x we have is log of 7 to base 5. This x value we will put in this equation. Equation was 5 raised to power x is 7. Now which can be written as 5, value of x is log of 7 to base 5, which is equal to 7. The next part is 2 as an exponent of 3, which means the similar that 3 raised to power any power x is 2. This is the exponential form, and according to logarithm, we will change the exponential form into the logarithm form, that is log of a to base b is x. So here we will change this equation into the logarithm form, that is log of a, that is 2, to the base b, that is 3, which is equal to a, that is x. So this is the value of x which we will put in this equation. The equation was 3 raised to power x, which is equal to 2. 3 raised to power, value of x is log of 2 to base 3, which is equal to 2. The next part is x as an exponent of y, which means y raised to power say x, that is equal to x. Similarly, according to logarithm, this is the exponential form. The logarithm form will be log of a to base b is equal to x. So this equation, that is y raised to power x, which is equal to x, will be changed into the logarithm form as log of a, that is x, and to the base y, which is equal to x. Now this is the value of x which we will put in this equation, that is y raised to power x, that was log of x to base y, which is equal to x. Our fourth question is evaluate each of the following by converting to the exponential form. We have this log of 81 to the base 3. This is the logarithm form. We know that logarithm form, that is log a to base b x, can be written in the exponential form as b raised to power x is a. So we will write this in the exponential form, that is 3 raised to power x, which is equal to 81. But we know that 81, which is the multiplication of 3 4 times. That means 3 raised to power 4 is equal to 81. 3 raised to power x is also equal to 81, and 3 raised to power 4 is also equal to 81. When 81 and 81 are same, that means 3 raised to power x is equal to 3 raised to power 4. If the bases are same, the parts will be equal. That means x is equal to 4. We have the second part, that is log of 125 to the base 5. We have to evaluate this. We know that the exponential form of logarithm is b raised to power x, that is equal to a. Here we have b base, that is 5 raised power x, which is equal to a, that is 1 divided by 25. 5 raised to power x 1. 25 is the square of 5. 5 raised to power 2. 5 raised to power x. When we will write this in the numerator, the power will get negative. That means 5 raised to power minus 2. Whenever we write denominator with any power in the numerator, the power gets negative. Now here the bases are similar, 5 and 5. Hence the powers must be equal, that is x is equal to minus 2. We have the next part, that is log of 8 to the base under root 2. The exponential form will be b raised to power x, that is equal to a. Here we will write it as b, which is under root 2 raised to power x, which is equal to 8. Under root 2 raised to power x, which is 8, can be written as 2 raised to power 3, which can be simplified into under root 2 as power 6. That means 8 can be written as under root 2 raised to power 6. Now under root 2 and under root 2 bases are similar, hence the powers must be equal. Hence x is under root 6. Next we have is log of 3 under root 3 to the base under root 3. The exponential form will be b raised to power x is e. So here we have b, that is under root 3 raised to power x, which is equal to a as 3 under root 3. We have under root 3 raised to power x, which is 3, can be written as under root 3 whole square multiplied by under root 3. We have under root 3 raised to power x, which is under root 3 raised to power 2 under root 3 raised to power 1, which will be under root 3 raised to power 3. Because if bases are similar and that is in multiplication, the parts get added. So under root 3x, which is equal to under root 3 raised to power 3. The bases are similar, hence x is equal to 3. Okay, so the fifth question is, find x in each of the following by converting to the exponential form. Now the logarithm form is given. The logarithm form is given and we have to convert it in the exponential form. So this logarithm form we will convert in the exponential form. B, that is base 3 raised to power x, that is 5, which is equal to a, that is x. 3 raised to power 5 is x, means x is equal to 3 multiplied by 3 multiplied by 3, means 3 is multiplied 5 times. And we know that 3 raised to power 5 is equal to 243. Hence this is the value of x, that is 243. So we have the next part, that is log of 216 to base under root 6 is equal to x. We have to change it in the exponential form as b, that is under root 6 raised to power x, which is equal to a, that is 216. Under root 6 raised to power x is, we know that 216 is equal to 6 raised to power 3, means cube of 6 is 216. Under root 6 raised to power x, 6 can be written as under root 6 raised to power 2 raised to power 3, that is under root 6 raised to power x. Under root 6 raised to power 2 raised to power 3, these both powers will get multiplied. That means under root 6 raised to power 6. When bases are equal, the values should be equal, that is x is equal to 6. We have the next part, that is log of x. Log of 1 by 243 to the base x is 10. In the exponential form, we will write it as x raised to power 10, which is equal to 1 divided by 243. We have written it in the exponential form. Here we have x raised to power 10, 1 divided by 243 can be written as 3 raised to power 5. X raised to power 10, which is equal to 1 divided by 3, can be written as under root 3 raised to power 2 raised to power 5. Okay, this is now x raised to power 10, which is 1 divided by, we know that this parts will get multiplied, that is under root 3 raised to power 10. X raised to power 10, which is equal to 1 divided by under root 3 raised to whole power 10. When the powers are equal, the bases should be equal. That is x is equal to 1 divided by under root of 3. We have next part of the same question, that is log of 1 divided by 4 under root 2 to the base x is minus 5. We will convert it in the exponential form, that is b we have as x raised to power minus 5, which is equal to a, that is 1 divided by 4 under root 2. We have x raised to power minus 5, that is equal to 1 divided by 4 can be written as under root 2 raised to power 4 multiplied by under root 2. X raised to power minus 5, that is equal to 1 divided by, we know that if the bases are equal, the powers get added when they are in the multiplication. This means under root 2 raised to power 4 plus 1, that is 5. Now we have x raised to power minus 5, that is equal to 1 divided by under root 2 raised to power 5. Now x raised to power minus 5, this we can write in the numerator, that is under root 2 raised to power minus 5. Now the powers are equal, hence x will be equal to under root 2. We have the sixth question as, if log of x to base 10 is equal to p, express each of the following in terms of x. First of all, we have 10 raised to power p. First of all, we will take this logarithm equation, log of x to base 10 is equal to p. When we will write it in the exponential form, that is b raised to power x, that is p, which is equal to a, that is x. Here we need to find 10 raised to power p. The 10 raised to power p is equal to x. We have second part, that is 10 raised to power p plus 1. First of all, we will simplify it as that 10 raised to power p multiplied by 10 raised to power 1. We know that the parts only get added when the same values are in multiplication. So 10 raised to power p multiplied by 10 raised to power 1. We know that 10 raised to power p is equal to x. 10 raised to power 1 is equal to 10. So this is 10x. We have the third part as 10 raised to power 2p minus 3, which can be simplified as 10 raised to power 2p multiplied by 10 raised to power minus 3. We know that if the power is in minus, then when we will write it in the denominator, the power will get positive, that is 10 raised to power positive 3. 10 raised to power 2p can be written as 10 raised to power p, 10 raised to power p, divide by 10 raised to power 3. We know that 10 raised to power p is equal to x, that is x multiplied by x divided by 10 raised to power 3 is 1000. So this is x multiplied by x, that is x square divided by 1000. Next we have 10 raised to power 2 minus p, which can be written as 10 raised to power 2 multiplied by 10 raised to power minus p. This can be simplified as 10 raised to power 2 divided by 10 raised to power p. Now this power will be positive. 10 raised to power 2 is 100 divided by 10 raised to power p, we know is x, that is 100 by x. This is our sixth question. We have our seventh question, a part, that is if log of x to base 10 is a, log of y to base 10 is b, and log of z to base 10 is a plus b. We have to express z in the terms of x and y. First of all, we have the equation, that is log of x to base 10 is a. This is the logarithm form of a equation. We will convert it in the exponential form as b, that means 10 raised to power x, that is a, which is equal to x. Similarly, we have second equation 10 log of y to base 10 is b. This will be converted in the exponential form as 10 raised to power b, that is equal to y, and log of z to base 10 is a plus b, converted to exponential form as 10 raised to power a plus b, which is equal to z. Now we have this equation, that is 10 raised to power a plus b, which is equal to z. When these powers are added, we can write it as 10 raised to power a multiplied by 10 raised to power b, which is equal to z. We know that 10 raised to power a, 10 raised to power a is equal to z, 10 raised to power a is equal to x. We can write here x. 10 raised to power b, 10 raised to power b is equal to y multiplied by y, that is equal to z. That means xy is equal to z. We have our second part of the seventh question. If log of x to base 10 is a, log of y to base 10 is b, and log of z to base 10 is 3a minus 2b, we have to express z in terms of x and y. First of all, we will convert all these logarithm equations into the exponential form, that is log of x to base 10a. When written in exponential form will be 10 raised to power a is equal to x, b raised to power x is equal to a. Similarly, log of y to base 10 is equal to b. In the exponential form, this will be 10 raised to power b, which is equal to y. Third equation we have is log of z to base 10 is equal to 3a minus 2b. This is the logarithm form. In exponential form, this will be 10 raised to power, that is 3a minus 2b is equal to z. Now we will take this equation. We have 10 3a minus 2b, which is equal to z. When there are two powers, we can write it in multiply, that is 10 raised to power 3a multiplied by 10 raised to power minus 2b, which is equal to z. This can be written as 10 raised to power 3a. When the power is negative in the denominator, it will change into positive, which is equal to z. 10 raised to power 3a means 10 raised to power a multiplied by 10 raised to power a multiplied by 10 raised to power a. Divide by 10 raised to power 2b means 10 raised to power b multiplied by 10 raised to power b. Now we have 10 raised to power a. Value of 10 raised to power a is x. That means x multiplied by x divided by 10 raised to power b is y. That is y multiplied by y. X multiplied by x is x cube. Y multiplied by y is y square. And all this equation is equal to z. That means z is equal to x cube divided by y square. We have C part of seventh question, that is if log of x to base 10 is a, log of y to base 10 is b, and log of 10 to base z is a minus b. We have to prove that log of z to base 10 and log of x divided by y to base 10 are reciprocal of each other. First of all, we will take this logarithm terms. We have log of x to base 10 as a. In the exponential form, this will be 10 raised to power a, which is equal to x. Similarly, the second equation, log of y to base 10 is b. That means 10 raised to power b, which is equal to y. Log of 10 base z is a minus b, which means that z raised to power a minus b is equal to 10. Now we will take this equation, that is z a minus b, which is equal to 10. Now when this is z, this is the power of z, that is a minus b. On the opposite side, this will be 1 divided by a minus b. that is means 10 raised to power 1 divided by a minus b is equal to z. This is the exponential form of a logarithm, that is b to x is a. In the logarithm form, this will be log of a, which is z, to base b, that is 10, that is equal to x, 1 divided by a minus b. Log of z to base 10 is 1 upon a minus b. Now we will take the second equation that we have, log of x divided by y to base 10. This can be written as log of 10. X is equal to 10 raised to power a. We will fill here value 10 raised to power a divided by y is equal to 10 raised to power b. 10 raised to power b. Log base 10, 10 raised to power a divided by 10 raised to power b. The values are similar, so the parts will get subtracted. That means 10 raised to power a minus b. When we have log of base 10, then 10 raised to power a minus b will be equal to 10 raised to power 1, because there is log of base 10. If values are equal, the parts must be equal. That means a minus b is equal to 1, which is equal to, that means a minus b is equal to the term that we solved, which is log base 10 x divided by y. Now what we have to prove it, that log z to base 10 means log z to base 10 whose value is 1 divided by a minus b, and log xy to base 10 whose value is a minus b are reciprocal of each other. For that, to prove, we have to multiply both the equation, that we have to prove the reciprocals, multiplied by log of x divided by y to base 10. Now we will fill the values. Value of log z to base 10 is 1 divided by a minus b multiplied by value of log of x by y to base 10 is a minus b. A minus b and a minus b will get cancelled. Hence the answer is 1. So this means if these are the reciprocal, then only the answer while multiplying them is 1. So we have proved that this and this terms are the reciprocals of each other. So students, today we have completed our exercise 6A of Logarithms chapter. If you have any doubt, then let us know your doubt in the comment section, or you can DM us your doubt on our Instagram page. Our Instagram account link will be provided in the description. Please do like and share our videos and subscribe to our channel. Thank you.